Welcome back to Murph Codes Python. We're going to continue our Python tutorial. We're going to take another look at our CRUDdy Buddy app that we wrote in the last one. We're going to handle a couple of problems. We're going to clean up our code. We're going to make this thing look good and readable. And also, put some documentation in so when you come back to it like 6 months from now, you're not looking at it going, what was I thinking here? Because we all do that. Let's get into it. Alright, so this is the source code of the app as we left it. A lot of random weird comments. A whole lot of this nonsense where we declare the variable and then use it. I do that during the development part to ensure there's no weirdness when I run it and it errors out and then I run it again and like the last thing I put in there is still there. Anyway. And I don't just do that for input, I do that for all kinds of stuff. Input would automatically just override whatever's in the variable once the input function is run on it. But anyway, it's a practice I got into. We don't need it for our final code though, because our final code should just work and we shouldn't be running into errors running the code. That'll leave a variable half populated or whatever. Anyway, one thing I did want to address is some of you using QPython 3L on your Android or iPhone devices might have typed in this code exactly as it's written here and been like, what the heck? This doesn't work at all. I get nothing but an error. We're also going to fix that too. Don't worry. Okay, so first thing we want to do is we want to organize some of our functions here and clear up some of these comments we've got going on. All right, like this here. We can just do that, and we don't need both of these comments, obviously. We're going to take this comment, move it up here to where our write file is. Because how do we update our file? We rewrite all of our output to it. That's how our CRUDdy app works. That comment is completely out of place because that isn't even where we're handling our record creation. But this is where we have our read file creation. We don't yet have a delete file operation for our app. We should at some point make one of those. So we're going to go and add a to-do tag right there, just to remind us this is something we're getting to. Alright, now one thing I also want to do is whenever we're doing a print statement that's a system operation or, or what have you, where something's going on behind the scenes and it's not just welcoming a user or giving a user information, but actually confirming something's going on. I like to decorate it a little bit, just as a way of setting it aside. Now, I don't remember how much of this we talked about. I know I addressed it a little bit, but what this is special string formatting, and we can use that and we will be using that a little bit later because we're going to make this app a little more functional. Because right now, all it's doing is saving a list of words to a file. I mean, you can get away with quite a lot on the back end of stuff if that's your methodology, as long as you remember what order those words are in and what they're supposed to be. But wouldn't it be great if you could open these text files up later and it's just an entire, like, Excel spreadsheet style report that you could go off of and just easily see at a glance what it's supposed to be? I think that'd be cool. It'd also be cool if it could save more than just, like, a name for each record. You know, what if we wanted to make these a little more complicated? Like, what if we wanted to give our kittens, you know, characteristics beyond just their name? We can do that. We can totally do that. Okay, so how this works is we have a string that has these special placeholder characters. $string, $S stands for string. It's holding a place for a word or phrase, and that phrase is held in a variable. This right here, followed by, you know, a list of stuff in parentheses, is just telling the interpreter that these placeholders will be populated by these when the program runs. We don't know what the file name is going to be when it runs, when the program, or before the program runs, until we type it into the program. So we have a variable, but we want to be able to use that file name in our code. This is how we do that. We put a placeholder, and we follow our string. This here is our string that has our placeholders in it, with the %, parentheses, and then in parentheses, in the same order as our placeholders, the variables we'll be using to populate those placeholders. Like I said, we're going to see a lot more of that in a bit when we write our more advanced record creation. But right now we're just focusing on our file creation. Now, we're going to use the same, we're going to use the same arguments here for our delete file that we did for the other stuff. But instead of opening the file, we're going to use part of this OS module that we imported. Can't remember if it's in the path or not. Oh yeah, we haven't imported it here yet. So let's do that. Yeah, if you ever try a help function like this to try to get information on a module and it spits out an error, it probably just means you didn't import it. So what we're going to look for here, because we've used exists to see if a file exists, what we want is to remove the file. Alright, it doesn't look like that's going to be part of our path. So we may have to just go up one. And by up one, I mean import the entire module. Oh my gosh, 2,000 lines. Expand it. Okay. Now, a lot of this is not going to make a whole lot of sense, because a lot of it's covering all the various class definitions for objects within the OS module. We don't need to worry too much about all of that. So we're just going to keep going down, keep going down, keep going down. Alright, functions. Here we go. There's a function for changing the current working directory. Changing access permissions for a file. We can count the number of CPUs in the system, which would be, you know, pretty interesting. I don't imagine that helping our CRUDdy app at all. I mean, we're not doing multiple processes or anything with this this particular app. We can get the current working directory. We can get the actual login name, the actual user's login name. So whoever ran this app, we'd know who that was. We could kill a process. We could create links. You know, like shortcuts and stuff to other files if we needed to. We could make directories. There's a lot we're able to do. Alright, here's the one we're looking for, though. So, make sure we're doing this properly. Okay. And again, just like in the previous ones where we're using these labels to represent our file directory and file name within the function, we're using those exact same labels. And when we call this function, we'll feed this the file directory and the file name, fully typed out, and those values will be plugged into filedir and file n and used throughout the function. Now, we don't want to just run a function and have it delete a file. Usually when that happens, that's a recipe for disaster. You end up just deleting stuff accidentally because you're not giving your user a chance to stop and go, hey, wait a minute. I didn't want to do that. And you should also give some kind of message that it's been done. Some kind of confirmation. So, for the use for this, we want to look at our file creation here. And we're going to do something a bit similar to that. Now, a lot of this we could probably just pull into here, but I kind of like leaving it out because that gives us a chance to change the way this operates in future uses of these functions. Alright, it's not totally tied in. So, we're going to change X to delete file. So in our menu here, we need to add a new entry. There we go. Now, if we've gotten this far, we know the file's already been checked for existence. Alright, because it has to pass this. Otherwise, the program doesn't continue. We've set it up that way. We're going to leave it that way. But we do want to ask if they're sure. However, you've seen these. We've done this twice now. And this actually is a fairly useful way of doing a very common task in any program, where you ask a user if they want to do something and you have a yes or no option to ensure that that's the way you're doing it. So what we're going to do, because that's such a common and useful task, we're going to pull those out. And we're going to rewrite those as functions. So back up here, underneath our create, update, read, and delete file operations, and we're going to make 2 of these. All right. Now, if you recall from our last session, the way these work is there's a default action, and in order to go against the default action, you have to actually type some kind of response that is acceptable as an indication of the opposite of the default. So, like in this part here, our default is yes. Our user must type in capital N, lowercase n, capital N-O, or just no, or just a lowercase no. Any of those options, and we're giving them plenty of options here, we'll say no. We'll absolutely kick that back. So we're going to copy that. Put this here. Let's call this confirm. And we'll still pass it a prompt so that, you know, when we use this, we can still customize the prompt that we output to the user. Because what I'm thinking is we're going to be using this in other programs down the road, not just our CRUDdy buddy. But like we'll be able to import this file into other programs, and we'll have this option to create a prompt that does all this work for us. Alright, so that's what we're doing here. We're making our code reusable. Alright, so we set up a variable to catch our input. Now I'm going to put a function here to turn whatever our prompt is into a string. On the off chance some idiot in the future, ourselves, decides that we're going to feed it a number and totally forget that it's got to be a string. We're just going to make it so that it doesn't matter what they feed in. We're going to turn it into a string. And then we're going to put this at the end so that we don't have to remember in our prompt that we need to put that at the end. We just have it there. Because as you remember from last time, or as you may remember from last time, pretty common thing you see in a lot of Linux command line stuff is there'll be, you know, it'll give you the indication of, okay, you have to type a yes or no, but the capital letter is the default action. If you just hit enter, it'll accept that as your answer. Hitting enter means you say yes here. Oh, I just caught that. We want to go with input, not input. Alright, so we don't have to remember to set up our prompts properly. Our function will do that for us as well. All we have to do is feed it the wording. You know, are you sure? Do you really want to do that? That kind of thing. That's up to us. Now, we want to write a condition check here. And this is going to be the same as down here. In fact, I'm just going to steal this. There we go. You can add all kinds of additional inputs here, just so long as it means no, because that's not our default action. If we want to give our user the option to say no, they have to go with an option that we've designated means no. It's a safety measure. always use the default action to take no action further in your code when possible. So like delete file, we're going to go with that default action of no down here, and they have to type yes in order to make it happen. Otherwise, it'll just not do it. That's the proper usage for these functions. Use them to where the default action will always take the least. Will always make the least change to your system or to your files, or it does the least of anything. Because if your user can't pass this simple check, it means that they're just randomly hitting buttons. They're doing it wrong. Someone's gotten on the system and, it's maybe some 5-year-old kid, look at me, I'm daddy, I'm doing the work. You want to make sure you're able to set up little safety checks like that, and this is how we do that. Why is that indenting so far? Oh, probably because I forgot that. There we go. It's nice how idle sometimes gives you weird hints if you know what you're looking for, that you've screwed something up. Alright, so where were we at here? Okay, we're creating our no function. Now what we want to do is we want to return if they've typed the non-default response. Like, have they done something that indicates they're alive and they know what they're doing and they really want to do the thing. Otherwise, we're going to return false. Okay? Now, don't get confused, okay? What this is going to do for this particular function is if the user types no, it's going to return true. Okay, that might be a little confusing. But the way it's going to work in our code is that's actually grammatically correct. Alright, because remember, the thing we're checking for is, does the confirm indicate the non-default response? Does the user input the not default response? And here, that would be true. They don't put in the non-default response. So we can take this and we can actually put this right here. We can take this prompt. We don't need the question mark because we've already covered that by adding it within our function itself. We can delete both of these lines because what our confirm function is going to do is it will return true or false. And if we're confirming no, which is what we're doing here, we're confirming a no response, this condition will check true because they said no, and it'll execute this. It'll say no, cancel the file creation, and then it'll exit the system. If they don't confirm a no response, the default action is yes. The default action for our confirm no prompt function will return false. That triggers our create file function. I hope that makes some kind of sense. I hope that makes some kind of sense. If not, rewatch this part a couple of times if you have to. Just rewind it, rewatch it, and it'll make sense. But this is not returning true or false in the response of true is yes, false is no. This is a true or false as in, are they overriding the default action? And in this case, the default action is yes, so they have to override it with one of the options we gave them here. And like I said, you can go ahead and add as many acceptable default option or override options as you want, just so long as it's something that means, you know, the equivalent of no or yes in the case of our next one, because we're going to do this a second time, and we're going to copy this pretty much verbatim. We're going to change this to a yes. We're going to change this to a no to indicate that no is now our default. We need to find our yes acceptable list. All right. And now again here. This one, though, might make actually more sense because here the yes does equate to a true response from our function, whereas anything else is a default no, which spits out false. So this one may be more intuitive than this one, but again, we're going for the opposites of, or we're going for two functions, and each one does the opposite. They do the opposite of each other. But the focus is, are they overriding the default option? All right, so where did we use this one? Let's scroll down here. All right, we've already replaced that. Here we go. We add in our prompt. We don't need the question mark at the end because it should set that all up for us. And then we can get rid of well, no, we can get rid of this one. All right. Oh, and here down here we've got it again. We can do, because this is another Y. Whoop. This is our prompt. We can get rid of this. All right. Now we could make this even simpler, and we could go like that. Because remember, if they confirm yes, our function returns true. So instead of making it an actual, condition check, our condition check is already within our function here. So done, which controls our program loop. Where is my program loop starting at? Right here. Here, done equals false to start it. If we make it true, that'll cancel this out because that becomes a double, or that becomes a false because while not done on false would be true, not done on true would become false. I know we've kind of made that super complicated, but when you think about it, it makes logical sense somehow. It'll exit out of the loop, and yeah. So let's see if we screwed all this up. Unexpected. Oh, what did I do? Oh, that's right. We forgot to include our delete file. And it helps if we can spell. It really does. It makes a big difference. Now, just like here, we want to be able to set this up so that we can't do that without confirming that that's what we want to do. We want to be able to say for sure that we've deleted the file. After we delete the file, it should kick us back up to here, where it asks for the file name. Save that. Let's see if we can run that now. Hey, there we go. Okay. Welcome to CRUDdy, buddy. Let's see. Our kittens file should still be there, right? Okay. So, first thing we want to do is we want to test if we can delete kittens. Whoops. Well, what did we do there? Apparently we screwed up our input, that's what we did. Okay. Are you sure? Yes. Let's see what happens. Okay, it says that it's been deleted, asks if we want to exit. We'll say no. It's going to ask us for a new file name. File not found because we deleted it. So our delete function actually works now. Works quite well. Now this is still a bit ambiguous. I want to make sure that they understand what they are deleting. So let's go to our prompt here. for our prompt, because our prompt is a simple thing. We don't want to go screwing that up with the... how did we word that here before? With the creation of the file? Okay. Whoop. What are you doing with that? Don't. Worst time for autocorrect. I swear to God. Alright, and in here we want our file name, file, directory. Okay, so this should let our user or our future selves know that what's going to happen is we're going to delete this file from this directory. Now we've deleted the kittens file, so we're going to have to go ahead and use a different one. Okay, kangaroo still exists. Let's go ahead and delete that one. Deleting kangaroos from that directory. Are you sure? Now if we hit enter, there's no message that says it was deleted. Exit? No. Does it still exist? It still exists. Okay. So, it gives us the proper prompt, which is what we're looking for. We've already tested if it'll delete the file. We know it does. Alright, we can quit the program just fine there. Alright. So we have these two. Now, it wouldn't make a whole lot of sense that these stay in our CRUDdy app. And that's where we always reference them from. At some point, what I want to do is I want to move those to a different file and then import that library into our CRUDdy app. For now, we're going to leave that where it's at, though, because it's in a good spot. It's fine there. It's fine. However, I did want to address one thing. Because this will probably not work as typed to anyone using the recommended app on your phone. If we go ahead and take out that, what this will do is it'll make the working directory the directory that we're already in. Wherever you put the CRUDdy file, that's the folder all of our files will be created in. That's the folder all of our deletions will be able to take place, any updating. It won't happen in any other folder. That's a pretty safe default action for our app to have. That means we actually would have to put CRUDdy into a folder in order for it to affect anything in that folder. The folder it's in right now, it's a pretty safe folder. We're able to just create and delete to our heart's content in this folder, it's fine. Now, that'll also mean we don't have to worry about the file path conventions of different operating systems, because we're building and testing this on Windows. If you've got this on CuPython on your phone, your directory paths are going to look different. They're going to probably not be anywhere close to a Windows system. And that's because Android is built off of Linux conventions. So it uses Linux-style directories. And the file tree structure looks like a Windows system, or a Linux system. With some modifications, because obviously it's Android. It's not going to be an exact, it's not going to look exactly like a Linux system file tree does. And iPhone, I imagine, similar. I've never worked with iPhone, but I have worked with Mac, and if they built their file system off of the way a Mac file system looks without completely reinventing the wheel, it's going to be similar to a Linux system as well. Now, I'd say we could go ahead and write this all up with Linux-style conventions for our directories and such, but then it wouldn't work in Windows. So, we could get around that by calling the current working directory, as you saw from our extremely lengthy help file. That is actually something we can do. Current working directory for wherever we're at. Now, I think that would actually be a pretty good idea. And it should work no matter what system we're playing around in. So let's see where that command was here. I want to say it was just CWD or get CWD. Here we go. We'll do that. So file directory. There we go. Now you could just leave it as the single quotes, the empty quotes, and it would work on whatever system. But a lot of our formatted text output to the user that tells you what directory the file is in would be short. It would just say, oh, deleted the file in deleted such and such file in no directory. It wouldn't have a directory there. It would just say deleted file in nothing. This way, we should still have some kind of output there. So, file not found, create it now. Yes. Now it doesn't look any different than when we did it before. But all of those are displaying our current working directory. So our program still functions the same way as it always did. Your output will look different on your mobile device if you're using CuPython 3L, but it should have the file path as it is on your phone. Okay, so it'll have something there. It'll just probably say, I don't know, something like emulated /0 /SD card /documents whatever. Like, it'll have something there, but it'll be the path to the file that you're playing with instead of, instead of this, because this is a Windows file path with the C drive. Your phone doesn't have a C drive. It doesn't. If it did, that'd be weird. That would be really weird. I mean, I'm sure you could create one, but why? Why would you want to? Okay, so we have fixed the issue of this program not working on CuPython 3L for some people. Or at least I hope we have. Yeah, I just ran it on my phone super quick, and it comes up with creating that same kittens.txt file. It says file kittens.txt located in /storage /emulated /0 /CuPython created. So there you go. It does work. It should print out the working directory. You should be fine. You can still use your file directory stuff there to get things done. Alright, so what else did we want to do to this? We wanted to clean it up. We wanted to make sure all of our output that was doing file work was actually formatted the same. So let's see here. Alright, we dealt with the file directory part. Well, CRUDdy buddy. I'm just going to throw a little comment there to let me know where the program loop starts. Alright, this is a system level sort of thing, so I'm gonna decorate that. I'm also going to decorate this one. Let's split this up into 2 print statements. There we go. Now, why did I split that up into 2? Well, because this and this are technically not the same thing. This is confirming that we're canceling the file creation, and then this is confirming the file was not created, that it doesn't exist. I know, we're just kind of splitting hairs there. Now, I think we can also take this out. Or is that going to make it so that... file not found. We're going to go with no. Yep, nope. See, if we go with no, that'll kick back with no error as soon as we try to read the file. So we do want to keep that in there if they don't create the file. For now, anyway. Oh, I know how we fix that. Adoy. Okay. This else is connected to the if statement right there. Right here, though, is another if statement that checks if the file exists. If the file doesn't exist, then we go into that. But if we wanted to make it so that it doesn't go into the rest of the program unless the file exists, we can just throw this here, and that should mean that the file must exist in order to do the rest of this. So now if we take this out, save it, run it, oh yeah, because we created a new block, we need to indent all this stuff. Everything within hold on. This should be an else here. Because if it's going to print no records, it shouldn't go ahead and then try to print the records. That wouldn't make any sense, would it? Because that's what this is doing. It's printing the records from our file that we read right here. So it's going to check if there's any records, and if there are, print them. Oop. So basically what we've done here is we've put the entire program into a loop that starts with an if statement. That if statement is going to branch and do one thing if the file exists, and do something completely different if the file does not. If the file doesn't exist, it's just this bit here that happens, and then it should loop back. It'll ask us to input the file name again, because I mean, just because we created it doesn't necessarily mean that's the one we want to work with. We might want to create another one. Now, if the file we entered does exist, it should go into all this other stuff. This is probably the least interesting part of this entire thing. Alright. Save, run. Oh. Thankfully, it does a real good job of making sure we indent it in all of the proper spaces. Okay. Does kittens exist yet? File not found. Create it now? No. Alright, canceling file creation. File not created. Hey, look at that. We are back to entering a file name. Kangaroos. Does that exist? File not found. Why, yes. Let's do that. Okay, kangaroos exists. Let's work within our kangaroos file now. There are no records. Alright, so let's add a record with Jack the kangaroo. We're not going to exit yet. Go back into there. We have one record. Let's add another one. Jill. No, we're not done yet. Just running through, checking the various things that we've changed, making sure it all looks good. Trying to execute all the various operations to make sure that they're still working properly, that we didn't break anything. Right there you can see we changed George to Tom. We removed Jill from the list. Let's try deleting the file. Deleting kangaroos from the thing. Are you sure? Yes. File kangaroos located in blah 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 has been deleted. Exit. Yes. Ta-da! Okay, so pretty much everything we've tried to do works. So let's just continue through here. Want to make sure we've gotten rid of our ridiculous extra declarations and our extra... Yeah, we don't need to do that twice. Of course, it's reading the file. Displaying the records there. Now we could turn this into a function. If we wanted to. We could also turn this menu into a function. Now, I don't want them to have to do just a capital A. Do a lowercase a as well, just as before. With the action that we were doing before, we could type in a lowercase b, a lowercase c, whatever, and it's just going to kick us out. Some of you may have run into that trying this out and testing it and not realizing that that's pretty much what's going on there. So this just makes it just a little more user-friendly. Get rid of all these extra things here. Let's go with D. D's a good one for delete anyway, right? Sure is. Again, we want to be able to highlight those system operations that are going to be taking place with a little decoration. Now what if we remove this? Do we need that? Let's find out. Now I probably shouldn't just delete it as such. Let's do that. What I've done here is I've just turned those two lines into comments. This is a debugging technique that you can use to test if certain lines of your code are necessary, or if they're doing what you expect them to be doing. So let's run that. Kangaroos still exists, right? File not found. Sure, let's create it. Okay. No records. Add record. Okay. So what this did was on our menu, where it gives us the ABC and Q option, we typed in Q, and it dropped down to our confirmation of exit. And because we're confirming exit instead of just exiting, that actually makes more sense. So I like that change. We're going to keep that. We're going to get rid of those. So there we go. Alright, that's our cleaned up program so far. It's not bad. We have our create file, read file, update file, and delete file functions. We have our little helper functions for confirming a no response, confirming a yes response. We've properly set up a current working directory to give us good output for whatever file system we're on. Alright. So that's all neat and tidy. Now, we can extend this further, and we can make this even better. Now, what I want to do is I want to make it so that when we start a new file, we're not just typing, we're not just adding an entry, and then another entry, and another entry, and that's it. That's all we can do with it. What I'd like us to be able to do is for the first entry, I'd like this to be headings. So we'd have a name, other data points, you know, as many fields as we'd like. And then each subsequent record would be you know, basically like a spreadsheet, you know, a little more functionality to our program. But what I want to be able to do is make it so that this is customizable, so that the user creating the file can create as many headers as they want. And then what our program will do is it will always read element 0, because that's what that is, that's element 0, as headers, and then it'll start at 1 for actual records. Okay. Now why am I talking about all this? Because we're going to improve our CRUDdy Buddy app. All right. So let's come down here. We're going to look at our file creation part, because that's where this starts. We create a file. Now inside of our file creation, it's just going to take the file and make it exist, which is a good start. It's a really good start. But we want to be able to set up headers as well, okay? Because once that file's created, we know, or we should know, at the same time as naming the file, what kind of information we want to put in it. So, we're not going to make that a part of the create file, though. We are going to make that a part of our create record, though. So we're going to copy this. This is our create record. Alright, and underneath our create, read, update, and delete file, we are going to start create record Whoops. I can type. I swear I can type. I've done it before. Alright. And we're going to define a new function for this. Alright, what did we call this? Create file. We want to call this create record. Now we're going to fill in what each of these does later. For now, though, I do want to create those functions. That's why we're putting this pass here. That basically means there's going to be something there. But for testing purposes, ignore the fact that where you expect there to be a big old block of code, that there's nothing there. Okay? We're telling the interpreter, we know, we haven't gotten to that yet. Just ignore it and trust us. Now, why are we going to make all of these functions when they work just fine as part of our menu? Well, because the same reason why we took our confirmation action prompts and put them in their own separate functions. Because we want to be able to take this this file and import it into other programs we design later, so that we do not have to rewrite this functionality. So we could create database programs, or we could create files and stuff that need programs just, you know, as they need them. If you were to make a game and you wanted your user to be able to save their progress or their settings, you could use this file that we're writing now in that future game program you write, so that you could create a settings file and you could have it save the user data and their progress, and like you've already written those functions for file manipulation. You don't have to worry about reinventing the wheel. You've already done it. We just have to make it more useful by putting it into functions that we can later import into other programs. But we also still need them to work in this program. So, I'm going to take a look here. Okay, so when we create the file, we should also create the record. Did I put anything in our create record yet? I have not put anything in our create record yet. So let's go down here where it's got add new record. And this is a good start. This is a good start for our function here. Okay. Now, we haven't declared within the in this function we don't have this file output. So what we want to do before we start adding to our file output, we first need file output. Which means reading in what's there. Since we haven't got anything there, and this is a create record, so this is going to just be, you know, but this should read everything that's already in the file. However, we're going to need to pass through those. We're gonna have to change up this this prompt here, because we're not just entering a name anymore. Because this could be multiple pieces of information. But at the end of our function here, it should take whatever new information we've come up with, added it to our file output that we got from here, and then we're going to read it back in, or we're going to write it back in. So that'll update after we add a record, and that uses the functions that we've already covered. I do want to take this out though, because I don't like that I've got a print statement inside a utility function. Because that's just a print statement. So let's take that out and find where we're using this create file outside of here. Alright, we're using it here. There we go. Alright. Now, if we end up using this this program or this function somewhere else in a different program, we don't have to worry about there being text output for no reason. Don't have to worry about it spitting out this stuff. And we're also going to take this out. There. Okay. I know, kind of a weird thing to suddenly decide needed to be done, but it did. It needed to be done because the whole purpose of these functions is going to be to just give the functionality to other programs later. I mean, yes, we're using it in this one, but we also want to be able to use it in other ones. In those other ones, are we going to want something spitting out to the command line that a file's been created or deleted? Not necessarily. We might be using a graphic user interface, in which case it would be kind of annoying to our user to have a command box suddenly popping up on the screen all the time. We can handle those notifications outside of the actual function that does the work. So, creating the record. What if we just already assumed that new data existed? And that was something we could pass in. Now you might be thinking, what? No. What? Are you crazy? Get out of here. Get out of town. Well, let's look at our create function here. I mean, it already exists here. We can now just take this out and substitute that in. I mean, that might seem pretty wacky. But this should still work. In theory. We haven't broken it. Everything still should behave properly. Where? Oh. Apparently we forgot to put pass at the end of that one. Okay. Save, run. Run module. What? That's because we forgot to add this bit. However, this isn't going to work without some kind of and so far we've just been doing name. Okay. So what's going on here? So far, we're not changing the format of the data that's going into our file. We're just changing the way we handle creating the file so that adding records immediately, that first record in particular, as a header, will just happen naturally. And that's a thing we can handle outside of our function. So, file not found created? Yes. Okay. Now, let's see. Alright. There's just name there. Which is fine. That's our header. Now we would like that to handle a little differently, because we don't want to be able to delete name. That's the header. So where we can delete records, we're going to change that so that the first record, it doesn't display. It's not going to display 0. We're going to change that. And we're going to do because we know the only thing in our file so far is one header, I'm just going to create a very simple string that's going to print out that header, and then it's going to go into this part where it actually lists each one. Okay. No records. Let's add a record. Type a name. Tom. Exit. No. No. I forgot there's the new line. So we should probably get rid of this. Just do that. I tried dressing it up. I shouldn't dress it up. I shouldn't dress it up. Whoop. Doing that wrong. Run that. Okay. There we go. Alright, so number indicating that this is the record number, name, Tom. Alright, one thing I want to do, because we can format, this right here indicates that this is a special character. The T indicates tab. So what we're going to do is we're going to do that here as well. And it should align everything. How cool is that? Now, I know y'all might be rolling your eyes going, that's not really that cool. I mean, it's pretty boring, actually. Now, one thing that seems to be an issue with this is it keeps adding an extra new line. I'm not sure if that's because I'm not stripping out the new line from our output or what, but probably. We'll deal with that in a future in the future though. But so far, we have better display of our records. We're now able to use the first record as a header. Now we just want to be able to increase the number of data entry points. This is going to take some thinking on our part though, because we do not know ahead of time how many data points we as a user of this program in the future will want. Do we want 17? Do we want 138? Do we want 4? I mean, for you know, readability's sake, we should try to limit the number of options we add, but like that should just be restraint we exercise ourselves, not something we actually have to impose. Alright, now one thing I want to do where is our kittens file? Says it's in the Python code. It's not there. That's presenting an interesting issue for me because that should be there. It should be there. I don't know why it's not. No? Okay. Huh. So now I'm perturbed, because where is it saving this stuff if it's not saving it where I thought it was? Ah! That's where it's saving it. We have got to fix that. There is no designation between the end of our directory and the file name when we add it. So it's sandwiching them together, and instead of creating a file in the directory that we're trying to target, it's going into the parent directory and sandwiching the last folder name and file name together because we did not separate those. So that's why it's doing that. But finding the file, opening it up, and we'll fix that later. We're actually coming to the end of the session here. We'll probably deal with this in the next session. You can see we've got our header and our entries. Now what I want to do is I want to make each of these entries a comma-separated value. A list of values, I should say. So when it reads a record, and then it goes to display that information, we're going to have to tell Python each entry up to a comma is a new chunk of data. And then the following bit of information up to a comma is another chunk of information. And to treat these all separately. But then to put them back together and write them to the file in the same order. We can do this with a couple of functions that are very handy, particularly if we're working with lists. And what is this if not a list? You know? I mean, yes, this is a list, but this is also a list. So what we would do is we would read this, we would split these chunks up at the comma, and then when we go to write it back to the file, we would just join them back together and stick a comma in between them. And we're going to show how to do all that. Hopefully when we get back. I don't have time to cover all that in 15 minutes. So we're going to do that when we get back. I'm also going to try to figure out how we can fix this this with the instead of putting this in the Python code folder, it's just sandwiching the two. We need to put our separator there. Now, again, that's going to depend on what your operating system is, because on Windows, our file and directory is this backslash, but in every other operating system, it's a / So, we're going to have to figure that one out. We're going to have to come up with a way to determine how our system separates out directories. Hopefully there's a function for that, but we'll figure it out. We'll figure it out. Anyway, I do want to thank you all for joining me for this wonderful, fun experience. Our program is looking a lot better. Our source code is actually looking tidy. And we'll be getting to this stuff pretty soon. But as you can see, this hasn't changed anything. We can actually get rid of that, because once we write out to the file, we're done there. And we've done that. We created a whole file with that. So yeah. Trying to think if there's anything else that I forgot to mention. You know, I bet there's a way using OS to figure out what the delimiter between directories is. I bet there's a way. Because that's the problem we're getting, is this doesn't have that last delimiter. So we just need to add that. But we need to add it depending upon, you know, is it this? Or is it that? And we have to figure out what the system default is. So let's add that to our to-do list. All right. But our program's coming along nicely. We have a lot of functions that we can actually use in other programs, and I'll show you how to use those in other programs later. We've got some very helpful confirmation input functions that we've come up with. Those will also help us inform functions we come up with when we get to graphic user interfaces. We've managed to pull our text out of our utility functions. There's kind of a practice with encoding to make the output separate from what's actually happening behind the scenes. The only time you would want those two so close together is for debugging purposes. But when you're actually, you know, working on a finished product, or, you know, making it into a finished product, you want to take all your output and separate that out, you know, from all of the functions you've created, because you never know when you're going to use these functions, and you don't want to be cluttering up your future programs with all of this extra text. One thing we didn't get to, and this thing actually I can get to, and we do have time for this. What if we were to come to this years down the road, and we don't remember what any of this crap does? This is called documentation. Now, sure, if you're someone who's got access to the source file, you could just read the comments. But what difference does this part make? Well, these are the help strings. And I'm going to show you real quick what this all does. Okay, so we're going to save that. All right. Oh, you know what? I better run it now that I've saved it. All right, we're going to quit. Yes, quit. Okay, now. Create file. Calling help on it. Okay. Apparently we have to include the arguments. Maybe if I just do that. Hey, there we go. Alright, so by not calling it as a function when I pass it to our help function, this is exactly what we wrote here. Now how does this work? Well, immediately after you declare a function or a class, as we'll see when we get to object-oriented stuff, if you take a string, put it between the triple double quotes, like I've got here. We're using the double quotes 3 times, so triple double quotes. You can type out just a real simple help function. Now this could be as complicated as you want. You could get real specific. Like I could do this. I mean, it's already there, so we don't have to. But we could tell the user that's file directory and that's file name. So let's run that again. Now the reason we keep running it is because it puts the updated version of the file we just created into idle's working memory. So we just want to get through here till we get back to our little triple angle bracket prompt. And then we're going to type in our help. So what this is going to do is it's going to find the function that we declared, and it's going to return that string that we just wrote. And there you go. So you can put notes for how to use your functions and what those functions do right in your code. Highly recommended practice for anything that you write that might become a library or that you may end up using later, like what we're doing with this CRUDdy app. A lot of this stuff, we're writing it the way we're writing it now is because we're hoping to be able to use it in future programs later. So this stuff is going to be very helpful for us because we'll be able to come back and go, you know, I don't remember what that did. But I know I wanted to use those to help with that. But, you know, what format do I do that in? Was it file name and then directory? Directory then file name? Well, I know. I'll check the help file. That did not indent anymore, did it? No, it did not. I was hoping that would indent more. Like, I do like that it added the white space there, though. Because this is what it does. These are the arguments. Like, you can put all kinds of stuff in these notes, anything you want it to display, and it will display it. It will display it for you so that you know what your intention was when you wrote it sometime down the road. It's also great for when you come back to these source files and you're reading them, because this is a little more information than just create file. Okay, create file. Well, what do these mean? Well, that's your file directory and that's your file name. So, start documenting your functions with this stuff. It'll come in handy. Anyway, that's it for today's session. This morning's session, anyway. We'll be back a little bit later. I'm going to go take a lunch. We're going to come back later. We're going to try to fix the issue we had with the directory delimiter and the file name. I'm going to see if I can think of a real clever solution for that. Hopefully I come up with something. Let's see. Oh hey, that was number 11 on our lesson plan, documentation. I managed to cover that. We'll do objects in importing and GUIs in future sessions. We're going to finish our CRUDdy app. We've still got 3 functions there to write. We've got to read the record, update the record, delete the record. But we want to be able to make it so that we can create more interesting records. Records that have more data in them. Not just a single entry, but multiple entries. So we're going to do that in the next session. Stay tuned for that. Thanks for watching. Follow to be notified when I'm live. I'll follow you back. Check out the Discord and the website if you feel like it. And have yourself a wonderful day.